welcome to Wednesday's edition of Cracking the Cryptic, where today we're going to be taking a look at a puzzle called Razwar by Dictionary. I've probably said both of those things incorrectly. Razwar, I can see, is an anagram of the word arrows, and Dictionary seems to be some sort of portmanteau word combining Derek with the word dictionary. But what I can tell you about this puzzle in terms of how it solves is that our testers say it's a case of sort of 2 + 2 is greater than 4, because we've got some Renban rules and some arrow rules which are being combined. I'll explain what the rules are in a moment, and they're being combined in such a way that the whole puzzle sort of acquires it becomes more than the sum of its parts. So we should be in for a treat, and it's meant to be quite approachable, this one. So do try and make some time and have a go at it. But before we get started with that, I need to tell you about some absolutely outrageous news that we've heard today. I'm very sorry to have to reveal this to you. If you've been following the channel for any amount of time, you will know that we have a secret that we only tell our very favourite people, and down the years we've let our viewers know the secret, and it's to do with the sum of the row and column in any Sudoku puzzle. Now, this is the New York Times crossword today. 42 down has just revealed the secret, willy-nilly. It's an absolute outrage. So no doubt those of you who follow the Cracking the Cryptic will have been able to write in the answer to 42 down fairly quickly. But, the secret is a delicate thing. It's a source of romance, and to just splurge it in a crossword clue like this, it's quite frankly sacrilege. Shame on you, New York Times. Anyway, what else do I have to mention? Lots of you are asking me whether I have solved the puzzle Inception yet. I have. I have, but I had a hiccup with it. So what I did was I solved it all, but between the Killer Sudoku part and the Star Battle part, I had to go and do the school run. So I paused my video and I came back later and I uploaded or exported the video this morning. And unfortunately, that last piece of it has totally corrupted. Well, when I say totally corrupted, as my cursor moves around the screen, all of the colour sort of runs in the video, which is quite amusing, but I don't think it will make for a very watchable solve. So I'm going to have to re-record that bit, I'm afraid, and that's all I can do. So I will try and get that done after I've done this video, and hopefully we'll be able to release that tomorrow. What I can reveal now, though, having solved it, it is a ridiculously clever puzzle. So Matches Martinka has, let me get this right, he's constructed a Sudoku grid which has some numbers in it. You can solve it as a Hitori puzzle, then you can solve it as an Akari puzzle, then you can solve it as a Nurikabe puzzle, then you can solve it as a Killer Sudoku, I kid you not, and then lastly you can solve it as a Star Battle. And I think perhaps the most remarkable thing about this is that each of the puzzles is a good puzzle. It's not like this has been done frivolously. Each of the puzzles stands on its own as being a really entertaining logical exercise. It's just ridiculous. It is a ridiculously clever puzzle. And yeah, it'll appear on the channel tomorrow. Anyway, that's all I've got to tell you about. Just please remember to subscribe. Please give the video a like. And please join us on Patreon, the best Sudoku club in the world. And now I will read the rules of Razwar by Dictionary, which are as follows. Normal Sudoku rules apply. Digits along an arrow, sum to the digit in that arrow's circle. So if you're not familiar with arrow Sudoku, the way this works is, let's imagine those cells were 1, 2 and 3. That square would have to be a 6, because 1 + 2 + 3 = 6. So that's how arrows and their circles work. Purple lines must contain a string of consecutive digits in any order. So these are so-called Renban lines. And the way these work is that let's say we worked out, in fact I've just worked out something about this box. I shouldn't have started there. Let's have a look at another line. Let's say we worked out that this cell was a 1. Now, if this cell's a 1, because this line has to contain a consecutive series of digits, this line would have to be a 1, 2, 3, 4 line. Now the digits can go in any order, so it could look like that, although that will break this arrow, but never mind that. In terms of the pure Renban mechanics, that would be a legitimate way of filling in this purple line. Similarly, if that was a 9, that could be 8, 7, 6, something like that. We can swap swap the digits around. They don't have to be in order. Do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking, and I'm actually going to start here because when I was about to do that example, I noticed that I have a given 4 today. Thank you, Dictionary. And that's rather important for this line, isn't it? Because we have to take a sequence of 5 digits. Now, if you think about the digits 1 to 9, imagine them lined up in a line, and we've knocked the 4 out. Well, the only set of 5 digits that we've got left that are consecutive are the digits 5, 6, 7, 8 and 9. So that must be the contents of this line, which means those digits must be a 1, 2, 3 triple. I could pencil mark. I mean, Mark would instantly fill in 5, 6, 7, 8, 9. Go on, I'll do it. 5, 6, 7, 8, 9 on this line. I don't like doing this, but we'll make an exception. And try and please Mark for once. Now, we've got another 5-cell line here. I think this is the only other 5-cell line. And if we think about the nature of a Renban, if you have a 5-cell Renban line, there's no way of taking a consecutive sequence of 5 digits from the digits 1 to 9 without including 5. So we know there must be a 5 on this line. Now, actually, I will also tell you that I think there is a 6 on this line. And that's because if I try and put a 1 on this line, then this arrow is going to be broken, isn't it? Because this arrow will then have to select its digits from a minimum of 6 plus 7, which is 13, which I can't put in a Sudoku cell. So there cannot be a 1 on this Renban line. So 2, 3, 4, 5, 6. We must get to at least 6. Now, what does that mean? I don't know. I don't think we can repeat that trick, though. I don't think you can say, well, you know, is there a problem with there being 2 on the Renban line? Because there isn't really. Because we could go 2, 3, 4, 5, 6, and then that could be 1, 7, adding up to 8. Okay, so we're going to have to look somewhere else, I think. Oh, I know what we could do. Yeah, look, I've only just noticed this. I've got some quite long arrows here. That's a 3-cell arrow. Now, a 3-cell arrow, I did this in the example, but there's more than just this one. There's that one. That's a 3-cell arrow. In fact, that one. Oh, in fact, there's loads of 3-cell arrows. So this digit must be 6, 7, 8, or 9 because we must add at least 1, 2, and 3 to get the total for the circle. So that's also 6, 7, 8, or 9. This is 6, 7, 8, or 9. And that's 6, 7, 8, or 9. 2, 3, 4. No, okay. Hang on a minute. Let me try and find something else to do. I think 1, 2, 3. No, so actually, okay. I'm now wondering whether this puzzle is all about where the 1s go, because a lot of these boxes have an arrow and a Renban line in them, and I don't think. Yeah, I mean, if you put a 1 on this Renban line, you have exactly the same problem on this arrow that you had up there. Because you're eliminating the ability of either of these digits to be a 1, 2, 3, or 4. So there'd be a minimum of 5, 6 pair, which add to 11, which is too big. So you can't put. So maybe this is what we have to do. Maybe we've actually got to highlight which digits in this puzzle can be 1s. So in that box, only those cells can be 1s. We've got 3 in box 2 that can be 1s. Now here, if we put 1 on the Renban line, again, this would totally break. 1, 2, 3 on the Renban line would cause 4, 5, 6 on the arrow, which is 15. So the only cells that can be 1s are those. And immediately, that's interesting. Because now we can ask where 1 goes in row 2, look. And the only 2 candidate cells are in row 2. So that cell definitely loses its bluage, doesn't it? And that cannot be a 1 anymore. Right, let's carry on with this. So here, again, we can't put 1 on the Renban. You can't put 1 in the circle because we're summing up digits to end up with the digit 1 if we try and do that, and that's just nonsense. Here we can't put 1 on the Renban or the circle again. I'm not seeing, well, there might be a pattern here, but I'm not seeing it yet. What about down here then? We can put 1 on the arrow. We can't put it on the Renban again, so we get sort of an L shape. Not sure. Oh, okay, right. I was about to say, this looks like an arrow, but isn't. It's a purple line. So this is a Renban line, but there's no arrow in box 8, so I don't think we can do the same trick there. What about this? Can we have, no, we can't put 1 on this Renban line. Oh, but that's not so useful. There's loads of cells that can be 1 in box 7. Okay, this was a total red herring, I think. I can't see what that does at all. There's only 2 spaces for 1 in column 8. That I can tell you is true. Is there anything better than that? No. Row 8's a little bit restricted as well, but not as restricted as column 8. Sorry. Okay, this is. I think I've taken the wrong path at looking at this. So let's carry on trying to restrict Renban lines. Because, right, that one's not so useful. We can say it can't have 1 on it, but that fact doesn't allow us to pencil mark anything onto it. What about this one? This definitely can't have 1 on it because that breaks this arrow. So 2, 3, 4, 5. Oh no, sorry, that's still not good enough. I was thinking that would get us, that would close the gap and allow us to pencil a 5 on this, but actually this could be 6, 7, 8, 9, couldn't it? So I still haven't bridged the gap by enough there. Bobbins. I'm doing appallingly badly. Right, this Renban line. Hang on a moment. Yeah, this is different. This is different down here. And this is different because, well, it's clear that 1 can't go on that Renban line. But I think even if 2 went on the Renban line, we'd have a problem here because this is a 3-cell arrow. So if we did put 2 on the Renban line and it was 2, 3, 4, 5, this would be a minimum of 1, 6, 7, which is still far too high. So this cannot have 1 or 2 on it. So 3, 4, 5, 6, and from the other direction we get, so there's a 6 on this Renban line. So I'm just trying to pick out sequences of 4 digits, and once we lop the 1 and the 2 out of the sequence 1 to 9, we're left with a sequence of 7 digits. We're having to select 4 of those digits, so you can see whichever way we cut that, you're always going to pick up the middle digit that's left, which is a 6 now. Now 2. I'm just wondering about 3 as well. In fact, if we put 3 on the Renban line, no, it doesn't work, does it? 1, 2, 7 is too high. Haha! So there's a 7 on there as well, I think, because I can't put 1. Yes, I can't put 1, 2, or 3 on the Renban line. So now the minimum Renban line I could make would be 4, 5, 6, 7. And if I take that from the other direction, I still pick up the 7 and the 6. So there's a 6 and a 7 on this Renban line. This is very interesting. Although I will admit I've got no digits in the grid yet. 8, 9, 6. Yeah, you can't actually put 1 on that Renban line, can you? Because it's only 4 cells, and that cell's a 6, 7, 8, or 9. And it is a Renban, so if that was a 6, 5, 4, 3 is the maximum digit you can put on this Renban. I'm not doing well at all. Oh, this will have the same profile as this, because that's a 3-cell arrow and a 4-cell Renban. But this is better. So just to reiterate the logic here, we worked out that a 4-cell Renban combined with a 3-cell arrow forced a 6 and 7 onto the Renban. Well, the same logic must be true there. Now that means that arrow can't be a 6 and a 7 anymore, so that's got to be an 8 or a 9. So there's no... Right, now we can't put a 9 on the Renban, because if we do that, the Renban will contain 8 and 9, and that will have no value. So 9 in box 5 has to be in one of two places. It can either be in the circle or in the corner, because it can never be on an arrow. Okay, and now we can we do any better than that? So if 9's not on the Renban, so 8, 7, 6, 5, oh, I forgot to put my phone on silent, or 2, 3, 4, 5. Ah, yeah, okay, this is sorry, I'll just put that over there. This is interesting, I think, because if we can't put 9 on the Renban and we can't put 1 on the Renban, we're selecting 4 consecutive digits from 2, 3, 4, 5, 6, 7, 8, and therefore there is a 5 on the Renban as well. Yeah, the same thing doesn't apply there, because there's no circle in the box that is operating like this 8-9 pair is operating, so we can't do the same logic down there. Now, what does that mean? Can we do any better than that? The answer is, I don't know. 5, 6, and 7. So this now can't be, it can't be 1, 2, 6 adding up to 9, because the 6 is on there. So if it's 9, and it can't be 1, 3, 5. So if this is a 9, that has to be 2, 3, 4. And that would be a 1 in the corner. And if it's 8, it would have to be 1, 3, 4. Oh, so there's always... Ah, that's it. That's it. Beautiful. Yeah, okay. So what digit is it that's always on this arrow now? Because it can't have a 5 on it, or a 6. If it's a 9, it's 2, 3, 4. And if it's an 8, it's 1, 3, 4. So there's always a 4 on this arrow, which means that this Renban has not got a 4 on it, but it does have a 5 on it. So the Renban is 5, 6, 7, 8, which means that gets sorted out. That is now 9, which means those squares have to be 2, 3, 4. Here's the only way of getting to 9 without using 5 and 6, and 1 goes in the corner. That's lovely. That's, oh, hang on, cycling through at the speed of light. Now we get a 1 in that box, look. We don't have a 9 here anymore. I've got a 5, 6, 7, 8, 9 quintuple in the central column. So these digits have to be 1, 2, 3, and 4. And that Renban can't have low digits on it. We worked that out. I think we said this 6, 5, 4. Yeah, 3 is the minimum we can put on this Renban. So this square is 3 or 4. 1 must be in one of those two positions in the column. 5, 6, 7, 8. 9 must be in one of those 3 squares. So 9 is not in that cell in this column. Okay. And what do we get as a result of this? Anything useful or not? Right, well, yes, I suppose this Renban line, if it's got a 3 on, well, even if it had a 4 on it, 4, 5, 6, 7, the maximum value that this can be now is 7. Because if it's 8, you could never tie these two together with only 2 digits between them. So this is 6 or 7, which means that this arrow is now must have a 1 and a 2 on it, because it's either going to be 1, 2, 3 or 1, 2, 4. So now, oh, that's weird. That's weird, because that hasn't advanced my knowledge of this Renban at all. I don't think. 3, 4, 5, 6. No, it hasn't. Well, I know this can't be 3, 4, 5, 6 because of the logic we did earlier. And now we can see that again. If it's 3, 4, 5, 6 on the Renban, you could never fill this in. This would have to be 1, 2, 7, and that would add up to 10, which is impossible. So, there must be a 5 in one of those two cells to link the 6 or 7 to the 3 or 4. So there's a 5 in one of these. I don't think that means there has to be a 5 on that Renban. This one? I don't know. I don't think this one is restricted. I mean, yes, it's true to say there can't be a 1 on it, because that will break this, but beyond that I have a horrible feeling I'm missing something about this Renban, because it is the longest Renban I've not actually managed to pencil mark. But surely all I know is that you can't put a 1 on it. If you put a 2 on it, that's fine. 2, 3, 4, 5, and this actually has options. It's providing it has a 1 on it, it's absolutely fine. This one as well, I can see it can't have a 1 on it, that's fine. What if it has a 2 on it? So 2, 3, 4, yeah, no, that wouldn't work either. So the 1 and the 2 in this box are in some subset of those positions. If there was a 3 on it, 3, 4, 5. No, 3 would work. 3, you could put 3 on the Renban, 3, 4, 5, and that could be 1, 2, 6 with a 9 here. Oh, you rotten thing. Okay. What about arrow logic then? I've got 5 arrow cells in row 3. So that's interesting, because what's the minimum numbers I could put into these 5 cells? Well, it's going to be 1, 2, 3, 4, and 5. And the thing about 1, 2, 3, 4, and 5 is, and the New York Times won't print this secret, is that they add up to 15. And that means these two circles must add up to at least 15. And that means that each individually must be at least a 6. Oh, that one can't be a 6. Hang on. So this digit now is a 7, 8, or a 9. And those two together have to add up to 15 or more. Well, now I can't put 9 on this. This might get interesting now, because I can't put 9 on this Renban, because then 9, 8, 7 will break this circle. Right, so where does 9 go in box 1 then? If it can't go on the Renban and it can't go on the arrow, it must be in one of 2 cells, which does absolutely nothing. Oh no. Okay, so if we can't put 9 on the Renban and we can't put 1 on the Renban, then surely I need 3 central digits for a 5-cell Renban. So don't I have to have a 4 on that Renban now? I do have to have a 4 on it. And there's a given 4, so there's a 4 in one of those 3 cells. This is really beautiful. Now that can't be 7. Because if that's a 7, how am I going to make this domino work? If I can't use 3, 4, 5, 2, or 1, 6, I can't make it work. So this square has become an 8 or a 9. Oh no, I can't. I don't know what these add up to, so I can't say, oh, that's got to be a 6 or a 7 then. Because these 5 cells could be adding up to more than 15. So can we narrow this down any further? If this is an 8, you can't make the domino work with 2, 6 or 3, 5. So if that's an 8, that has to be a 1, 7 pair. 8, 1, 7, and that would just leave enough 2, 3, 4, 5, 6. Yeah, that only just works, but it does work. You get 2, 3, 4, 5, 6 on the Renban, and a 9 in this cell. Okay, and if this is 9 then, well, this couldn't be 4, 5 or 3, 6, so it'd either be 2, it couldn't be 2, 7, because that wouldn't leave enough room. hang on, is that right? I think that is right. I'm just trying to think about how 9 could work here. If that's 9, we have to go 2, 7 or 1, 8, but 2, 7 won't work because between 2 and 7 you've only got 4 digits and I need 5 consecutive digits. So if this is 9, that has to be 1, 8, and therefore there is definitely a 1 on this line. And that's probably important for some reason I can't figure out. Why is that? Why is that mattering? Well, so there's a 1 on here now, which we already have taken into account in computing the Renban. So there's a high digit on here, which is going to join some high digits over here. Ah, no, I see it. I see it. There we go. There's a 1 on this line, so this arrow on this side has to be 2, 3, 4 now. That's the absolute minimum we can put on it, and we can't put any more on it, or this would be higher than 9. Oh, this is beautiful. So that becomes 9, and that becomes 8, which means that is a 1, 7 pair. Oh, hats off. That is very, very cute. And now those are, so 9 has to go in the corner. 9 has to go here in box number 2. 7 comes out of those 2 squares. And we can fill in the contents of the Renban line now, which must be 2, 3, 4, 5, and 6. But that can't be 2, 3, or 4 because of the 2, 3, 4 triple. So this is 5, 6. We've got a 5, 6, 8 triple in row 3. We can take 4 out of those cells. Can we do better than that? That can't be an 8. I'm not sure. 6, 7, 8. Yeah, okay. Where does 7 go in this box? Look, 7 has to be vertical, and that 7 is looking down at those 2 cells, so they can't include 7 anymore. 2, 3, 4. So this, okay, now where does 1 go in this box? 1 can't go on the Renban, we've always known that. So 1 is in one of 2 positions. I've just remembered something. Where does 1 go in column 8? We said 1 could only go in 2 positions. One of those positions was here. Because look, we've got Renban lines all the way down. So it's either got to go in one of those 2 cells, so it's got to go here. So that's a 1. And this Renban line now, we're selecting from 3 cells from 5, 6, 7, 5, 6, 7 and 8, aren't we? That's all. So this has got to have 6 and 7 on it. And that's got to have 6. Oh, this is sick. Right, okay. That is absolutely beautiful. Look at this. We've got a 6, 7 here and a 6, 7 here. So we should immediately be turning our attention to where 6s and 7s go in column 7 of the grid, because they cannot go here and they cannot go there. So 6 and 7 belong in 2 of these 3 cells. Well, you can't put them on the arrow. There is no way. They will add up to 13. And what you also can't do, once you've decided that this square needs to be a 6 or a 7, well, it can't be a 6 and have a 7 on its arrow because you can't accompany it with -1. So that square's got to be a 7. That's got to be a 1, 6 pair. That fixes the 1 in box number 3. Don't know what else that does. Probably loads. Yeah, I mean, it must do a lot of damage to this 4. Yeah, how many digits are there between 1 and 6? Well, there are only 4, so that's got to be 2, 3, 4, 5. And we've got to put 8, 9 in the sides of the grid here. Okay, now what do we do? We can, well, I've got a 2, 3, 4, 5 quadruple in column 8 I'm now seeing, so that square's got to not be 5 because the 5 in that quadruple is definitely in that triple. So these cells are 6, 7s, 8s and 9s. This puzzle is really, really very good. Look, now I've got a 6, 7, 8, 9 quadruple in this column, but the 9 can't live in those two squares anymore. And why is this so powerful in a Renban puzzle? Well, we've now placed a 9 in one of those two cells on a Renban. So this Renban at the bottom, once you know it's got 9 on it, you can just fill in all its digits. It's 9, 8, 7. Oh, I see, and we've got a 9, 8 pair here, so that becomes 6, 7. So this isn't 6, 7. Now we can eliminate 8 from up there. Oh, yes, okay, no, simpler than that. Where does 8 go? In box number 3 now, it's got to go here. So that means this square's got to be a 5 by Sudoku. Good grief. And we can get rid of 8 from that cell. Aha, now I've got a 5, 6, 7, 8 quadruple in this column, but look at where the 8s go in that quadruple. They go on in this domino, so those cells can't be 8 anymore. That square can't be a 5 anymore. There's a 6, 7 pair here, so this, I can take 5 and 6 out of that. Okay, I've got 2, 3, 4 triple in row 2, and the 4 is over here. I don't know if I can do better than that. Probably can, but I'm not immediately seeing how to. So column 8 is all but done. I just can't eliminate or pare any of these cells down any further. Yes, in fact I've done the same in column 9. I've got it all down to either pairs or triples. I need to put 5 into column 7, so these squares at the bottom, one of those two cells is a 5. And I'm not doing too badly at using up my Renban clues, although I am a bit nervous because I haven't actually spotted anything I can do from here. So there must be something. Where do we look now? What is going to be the natural place to find more deductions? I don't know. 4, I suppose maybe it's Sudoku. I can get rid of 4 from this cell. That does give me a 2, 3 pair in this column. So I've got a 1, 2, 3, 4 quadruple down there, which means everything else in the column must come from 5, 6, 7, 8 and 9. But this square is on a Renban. So that must only be 5, 6 or 7, mustn't it? We can't put 8 on this Renban, that's too high. Because even if we make this 4, 5, 6, 7, we can only get to 7. So that's a little bit interesting. Oh, I tell you something, I've got a 6, 7 pair in row 7 I've only just spotted, so that's having an effect on that arrow. So this arrow's down to 8 or 9 now, which gives me an 8, 9 pair in row 7. So, okay. So those 4 digits are 6, 7, 8 and 9, which means the rest of the row is from 1s, 2s, 3s, 4s and 5s. Now, that square can't be a 1 and it can't be a 5 because the 5 is on the Renban. So this is 2, 3, 4. There's a 2, 3, 4 triple in column 4. So let me just think about this. We've got a 1, 2, 3, 4, 9 combination down column 4. So the digits we're missing are 5, 6, 7s and 8s. So these digits are from 5, 6, 7 and 8. But that can't be an 8 because we know that that's on this Renban line. So now I've got a 5, 6, 7 triple on the Renban, which can never connect with a 3. So that square's a 4. Which means we can do some tidying up. Look, we get the 4 in box 5 now. We've got, take 4 out of this square. Ooh, and I've got a 5, 6, 7 triple in column 6, so that must be an 8, which means that's not an 8. So now I've got a 5, I see, so I've got a 5, 6, 7 triple in column. Oh, no I haven't, I've got a 7 there. So better, I've got a 5, 6 pair in column 4, which means that square is a 7, which means that square is a 6, which is on the arrow. Oh, this is lovely. Right, so that's a 5. So this square is a 7, it's just fill-inable. And in fact, in this column, I could have asked the question where 9 goes, and it must go at the bottom. That square is now not 5 or 6 or 7, that is just an 8, naked single. That square can't be 4 because there's a 4 in the box, so I'm left with a 1, 2, 3 triple in this box. That square, don't know. 5, 6 is... I've still got this 5, 6, 7, 8 quadruple in column 5 that I can't see how to do. Can we do better than that? Probably can, but again, I'm not seeing how. This 6 and 7 are doing some work on the right hand side. Look, so that's a 6, that's a 7. Although that's not affecting anything vertically, so I'm not sure how much further we'll be able to take that. 1. This cell can't be a 1, so we can place the 1 in box number, this box, whatever it's called, box number 8. Those can't be 1s anymore. Now, okay. I've got a 2, 3 pair in this row. So that's a 4. And that's a 5. Here we go. So that's a 4, 5 pair. I get a 2, 3 pair here. This must be done somehow. How is this getting resolved? There must be a 7 over there. There must be a 4 down here. Don't think I can resolve this 1, 6 pair. I've got 2, 3, 4, 5 and 9 here, so I need 1, 6, 7 and 8. There's an 8 here. That's 1, 6 or 7. These are 1, 6, 7 or 8. I'm going proper pencil mark today, aren't I? I'm sorry about that. I don't normally like to do this. But actually I have found it a little bit helpful with the Ren bands, because they seem to be very amenable. Once you can get a high digit on them or a low digit, it really seems to matter. Now maybe it's this arrow then. I've got to put... It's a reasonably sized arrow. If it had a 1 on it, if this was an 8, I would know this was a 1. I get 1, 7, 6 immediately, which would be very handy. 6. 6s and 7s, look, in rows 7s and 8s have to be in 2 of those 3 cells. Well, you can never put 7 on the arrow. So this square... I mean, if that's a 6, that has to be a 9. Right, beautiful. Right, this doesn't work. This is not a 6, because if that's a 6, that has to be 2 and 1 on the arrow. So far, so good, but I've now got to put 7 in both of those squares, which won't work. 1 and 6 come out of that, that's got to be a 7. 1 comes out of that, and we have double 7, which is nonsense. So that is rather beautiful. We can get rid of 6. We get a 6, 7 pair in the corner, which means this square is now 2, 3, 4, or 5. Oh, and this Renban line now, is this restricted? Because, yeah, we've got 4, 5, 6 and 7 in row 8. So this, yeah, that simply can't be a 6 because the consecutive digits, which are 5 and 7, are not available because of the row. So that is 7, this is 6. Now I understand why this tiny little Renban's been put in the grid. That's beautiful. So that gets us a 7 and a 1 there. So this becomes 1 or 6. We can take 6 out of this square. We can take 7 out of this square, and 1 actually. So this is down to 6 or 8. And that being a 7 means this is an 8 on the Renban, which means that's an 8 and that's a 9, which means that's a 9. I was not expecting that. Oh, okay, but that's... Okay, and these digits are from 1, 2 and 3. So this is not 1, 2, 6 because of this square. So it's either 2, 3, 4 or 1, 3, 5. Now, I suspect I should know which of those it is, but I don't immediately. How are we going to work that out? I know how we're going to work it out. This little 1 here is looking at that cell. So now there has to be a 1 on the 9 arrow, and once there's a 1 on it and it's not 1, 2, 6, it's got to be 1, 3, 5, which places a 2, and something there, a 4. So that becomes a 3, that becomes a 2. I've only just noticed I hadn't done that 6 arrow, so apologies if you've been shouting at me about that. Now those two squares now have got to be a 4, 5 pair, which is resolved by this 4 there over that side. So 4 and 5 go into the grid, 2 and 3 go into the grid using this digit. This 3 and 2 go into the grid. That becomes a 2, that becomes a 3. Suddenly the world is becoming simpler, isn't it? Now we've got a 3, 4 pair here, so we can take 3 off the arrow. And what does that mean? I don't know. We've got a 5, 6 pair. We've got 2, 4 pairs. Oh, look, the 4 down here we can do. So the 4 and the 2 go into the grid. And perhaps we get stuck. I guess we've got a 1, 3, 5 there. So that forces this to be 6, which gets us the 6 and the 1. Okay, so we can carry on for a bit longer. This now is an 8 by Sudoku. We haven't got a 7 in the row, so that's got to go here. This 4 is giving us the 4 and the 3. So 3 must be in one of those two cells. 4 must be in exactly this cell. And the digit that we're missing in this column is a 2 into that cell, so that I can see is useful. That gets the 2s and the 3s all resolved. And hopefully this, the 6 is done. That 6 is done. Look, we've got to put 6 here. That all goes in. So that becomes 6 and 7, which finishes off this presumably. 7 goes here, 5 goes here, 6 goes here, 5, 8, 6, 8, 9, 9 in that cell. We need 1 and 5, which looks like it's working, and something that should resolve all of this. I've made a mistake. No, I haven't. Phew. 3 goes here, 5 goes at the bottom, and 1 goes here, and we click tick, and no, we haven't made a mistake. That is a big relief. That's a really clever puzzle. I see exactly what the testers were saying. It's very peculiar how even relatively short arrows are rendered incredibly interesting when you combine them with the Renban rule. And especially, well, I started off thinking about once, which I think was it was a red herring, but it did at least put me on the right track, because then I could start to think about the fact that on some of these Renbans you couldn't even have a 2, and then this central Renban was the key, and the interaction between this circle and this 4-cell Renban is genuinely very interesting and very surprising. It's a quality puzzle, Derictionary. So thanks very much for sending it in, and thanks for watching the video, and we'll be back later with another edition of Cracking the Cryptic.